Hey folks, welcome to this session. And what do we do this time of the year? We come to reinvent, learn about the new things about AWS. And I'm sure you are also a customer of AWS and you are accessing remotely your applications and resources in AWS to do your daily job while you are in the conference. And this is the best place to learn about how to securely connect to your application and resources using AWS Verified Access. We launched AWS Verified Access 2 years back. It provides zero trust based connectivity to your HTTPS applications on AWS. Now I'm happy to share that we are starting a new chapter for AWS Verified Access. We are supporting resources accessible over non-HTTPS protocols like TCP and UDP. I am Shovan Das, I am a principal product manager, and I have Rajat, who is also a product manager working on Verified Access, and I also have Bashuman Deb, who is the principal engineer and designed this system. Roughly we will give an introduction about Verified Access, why we build it, and then I will hand it over to Rajat, who will talk in detail about the feature we are launching, and then Bashuman will take over and give you a console walkthrough of how the feature works, how to set it up. And at AWS we have different kinds of customers in different, and they prefer different connectivity methods to access their application and resources in AWS. And we support all of them. We want to provide best in class connectivity method for all our customers. We have customers who connect their users to their on-prem networks, and these on-prem networks are connected to AWS. We have services like Direct Connect, site-to-site VPN, which connects your on-prem network to AWS network, and that's how your users can access all the applications remotely. Then we have customers who said that, hey, I want my users to connect directly to AWS and the network and all the applications in the network. So we came up with service called AWS Client VPN, and that gives connectivity to your network in AWS. And then few years back we learned from customers that they want more granular controls on who can access what set of applications. And this was more of a security ask, but they also wanted ease of use. So essentially they were saying that, hey, we want zero trust connectivity to our applications in AWS. And before we go deeper, zero trust can mean multiple things to multiple folks. So it's good to set what it means for AWS. In AWS it means two things. We recommend that with networking signals, you also use non-networking signals to establish trust and then grant access to your users. One of those non-networking signals can be user's identity, the corporate identity. And the second non-networking signal can be device posture, whether the device is compliant, whether it meets all your requirements or not. The more signals you use, the better the trust evaluation is and better the security posture of your applications. The second thing is continuous validation. What it means is that, let's say I want to access application 1. Based on the zero trust principles, we recommend you to validate my identity, my device posture, and then give me access to application. Few moments later, if I want to access application 2, then also you use my identity, my device posture, run it against the access policy for that particular application, and then give me access. So it's a continuous evaluation. And based on that, we built AWS Verified Access. And when we built AWS Verified Access, we had three things in mind. First and foremost, it should provide easy access to your remote users, so it should increase your workforce mobility. No matter where the user is, they can easily access the application. The second thing was security principles, where we help you to enable better security posture for your application through the zero trust principles that I talked about. And the third thing is that although you will write policies for each application, granular policies for each application, but at the end of the day, we want you to have an easy management experience. AWS Verified Access helps you to manage all the policies in a simple and easy way, and we will cover that. To give an overview of how Verified Access works, it's a managed reverse proxy. When your users type the domain name of your applications on their browser, all the HTTPS request, it comes to AWS Verified Access. AWS Verified Access is integrated with your identity provider and with your device management provider. It pulls all the signals and it helps you to write the policy. Based on those policies and based on the signals, it evaluates if the user should have access to the application or not. If the policy says yes, users has access, then AWS Verified Access connects the connection to the application residing in your VPCs and then within AWS. It also logs each and every access request, and that helps you for audit purposes, or let's say you are investigating a security incidents or simply troubleshooting connectivity. You can use that log for all these purposes. It has been there in the field, and many of our customers are using it for production applications. And I wanted to share a few feedbacks that we got from our customers. And in the customer side, there are three stakeholders. First is the customer itself, the organization. They said that, hey, we wanted an easy way to onboard to Zero Trust, and Verified Access provided that. We built a open partnership model where we can integrate with any identity provider and any device management provider. And that helps you because you have to change the least amount of systems in your IT to onboard to Zero Trust. And we have this set of partners. We have partners on the identity side, we have partners on the device management side, and we have also partners who consume our logs and then give you rich analytics for the purposes that I just talked before, audit or investigation of security incidents or just simply troubleshooting. Then the second stakeholder is the administrator. From administrator perspective, no matter how many applications you have in how many VPCs, you can just centrally manage the entire access and all the permissions and grants at one single place. It's an easy way to manage and set up. The third, and I will cover how from an administrator perspective how it is easy. So from an administrator perspective, you create verified access and you simply write policies. When you onboard applications, what happens is that we will connect the reverse proxy with your application VPC wherever your application is. So we will drop a point-to-point interface. That way, you don't have to manage any appliance, you don't have to manage any connectivity or what typically is called connector between your policy enforcement point and your VPCs. So you simply spin up verified access, write and manage policies, and that's it. And we will take care of the backend connectivity to your application. The third stakeholder here is actually the developers, because they are writing all these applications and they want to onboard and productize the application as seamless as possible. So verified access supports a seamless onboarding mechanism for the developers. From developers perspective, it doesn't need any backend communications like emails or tickets to onboard their applications. And how it happens? The administrator writes policies. An administrator can say that, hey, this group of policy is for my productivity applications. This group of policy is for my finance application, and this group of policies is for my engineering applications. And all these policies are shareable using AWS Resource Access Manager. So all the policies you share with the right development team with the right AWS account, and they onboard or add their applications to the policy. So from administrator perspective, you write, manage and edit the policies. The developers, they can't edit or change the policies, but they can onboard to the right policies. So that way, it is a frictionless model, and if your organization has hundreds and thousands of applications with multiple development teams, so they can just work without getting in the way of each other. As I said before, verified access till now supports connectivity to HTTP applications. These are web applications, for example, your corporate directory or your marketing dashboard, which your employees or your users will access using a standard browser. Now, we are starting the next evolution of verified access, which is support for applications and resources which are supported using TCP or UDP protocols. So, this can be like SSHing into an EC2 instance or accessing your database, or simply you might have applications or servers which users connect or your admins connect using a TCP or a UDP client, right. So, all those things are now supported using verified access using the same zero trust principles. So, how does it work for non-HTTP application? Let us say same thing, I want to SSH into a EC2 instance or I want to access a resource. So, when the connectivity is established, verified access will pull your identity information, device management information, run it against the policy for that particular non-HTTPS endpoint and then grant me access. Moment later, let us say I want to access something else. So, it does again the same continuous verification, it runs the policies against that particular resource, and also some of these sessions are long lived sessions. So, verified access in between the session also evaluates the posture because something might have changed, and if something has changed and if the policy says that hey we should drop the session, it will drop the session. Right now we are supporting at 15 minutes granularity and we will add more configurations as we go forward. So, now I will hand it over to Rajat who will give you more details about the feature.
Thank you, Shovan. So, let me share what we learned from our customers, what are the challenges that they face today in providing access to non-HTTP resources and applications. So, from our customer interviews, we learned that non-HTTP resources can broadly be bucketed into two categories. The first are persistent resources, which are more stable components of your architectures. These could be applications, developer tools, databases. Your developers access tools, code collaboration tools such as Git repositories, or your data analysts query data from database platforms such as Amazon RDS. These components remain a part of your architecture for a long period of time until you upgrade or migrate from them. The second type of resources are more ephemeral in nature. These are temporary components of your architecture and scale dynamically up and down to meet your application's needs. For example, EC2 instances spin up to meet high traffic requirements of your applications. And once the high traffic subsides, the EC2 instances are terminated. Let's look at the challenges that we heard from customers that they face today. So traditional solutions of remote connectivity still rely on network-centric security controls, which are IP-based, so that involves only IP allow listing and do not take in any other kind of signals, such as user's identity or device posture, into consideration when granting access. Further, access is only evaluated once when the user is connecting or connecting to the app, which leaves room for evolving threats. And finally, solely relying on static credentials. Static credentials are necessary for certain legacy apps or databases, but these are hard-coded usernames and passwords and do not provide any kind of mechanism to audit or revoke access. So if a user changes their team, role, or leaves the organization, they might still retain access to sensitive data. Further, admins spend a lot of time writing automation scripts to clean up these credentials once users move around. So to cater to these issues, customers prefer using their identity provider to authenticate users and then authorize them access. And to do so, they use DIY or other existing solutions. Now, although DIY and existing solutions do allow you to use identity-based authentication and authorization, they do come with some management overhead. IT teams have to deploy appliances and manage their underlying infrastructure, which includes monitoring, patching, securing. Further, no matter how you deploy your appliances, be it in each VPC where you have resources that need to be accessed, or in a central VPC, you still have to configure appliance to resource routing. In addition, onboarding becomes a challenge, especially for dynamic resources. If you're using traditional remote connectivity solutions, you have to update your network access control lists. But if you're using newer solutions that provide granular resource access, not access to the entire network, but each resource, and offer capabilities such as defining resource level access policies, you have to go and manually register each resource that is created to provide management access. This involves exchanging credentials and ensuring that vendor systems are properly integrated with these appliances. Again, adding to management overhead. So based on this feedback, taking this into consideration, today we are announcing the public preview of Verified Access new feature, which enables non-HTTP access. This feature improves your security posture, simplifies your security operations, and ensures that you can onboard resources at scale. Let's take a look how. We're launching support for 2 new endpoints. We already have support for HTTP endpoints, which is used to provide access to web applications. We're launching TCP endpoint built for persistent resources. You can now simply enable zero trust access for your tools, applications, and databases, and eliminate relying on static credentials only. And we're launching another endpoint, the network endpoint, which is built for ephemeral resources. Let's see how these endpoints, what are the benefits of these endpoints? So as Shovan mentioned earlier, Verified Access already supports granular fine-grained access policies, which are based upon users' identity and their device security status. Now you can extend the same set of policies that you used for web applications earlier to also for non-HTTP applications and resources. Further, access is continuously evaluated throughout a user's session. So for example, if a user's device compliance state changes over time or because of a malware, the access to applications for the user is immediately terminated mid-session, ensuring your applications are always safe. Further, now you can augment your legacy applications or databases which have a dependency on static credentials with zero trust based access controls. Because Verified Access is already integrated with the identity provider, you can enforce additional security such as multi-factor authentication or even revoke access centrally, making your IT operations easier. So one of the feedbacks that we have received from our customers over the last 2 years is that they have really appreciated ease of onboarding and ease of use. So in Verified Access, you simply have to specify the resources that you want to enable access to for your end users, and it takes care of all the networking and routing from the endpoint to your resources that you specify, providing you an end-to-end managed experience without having to worry about setting up appliances and managing its underlying infrastructure. Further, you can onboard a group of resources on a network by defining the network. Verified Access will continuously monitor that network and ensure that if any new resource is spun up in that, it will enable connectivity to it. But I want to emphasize on a nuance here that it still provides granular resource access. So every time a user connects to a resource, their access policy is evaluated. So if a user is connecting to 2 different resources on the network, the access policy will be evaluated every time a resource is connecting to just one individual resource. Their access attempt and access evaluation outcome is logged every time. And further, you can have fine-grained access criteria for each and every individual resource in the access policy, allowing you the flexibility to have different levels of access security depending on your application's needs. Now, we've heard that it's quite easy to onboard, easy to operate, but let's dive into how you onboard resources onto TCP endpoint. So today, Verified Access supports 3 targets: the network load balancer, application load balancer, and a network interface. With this launch, we're also adding support for RDS instance, RDS proxy, and RDS cluster. So you simply specify the resource that you want your users to access. And once you create the endpoint, Verified Access connects the endpoint to your resource and also provides you with a vanity DNS name. Now you have to CNAME this DNS name to the DNS that your end users are already using today, or you want your end users to use. This ensures that every time a user tries to connect to the application, the request first goes to the Verified Access endpoint, where the policy that you define is enforced. And based on the policy outcome, only permitted users are connected down to the application. Now, CNAMing for persistent resources is a one-time step, but doing so for dynamic resources, again, can add to operational inefficiency. So instead, for a group of resources, verified access generates the DNS records, which are publicly accessible for every resource behind a network endpoint. And to do so, it leverages a subdomain that you can delegate to us. So from your enterprise's domain, you can delegate a subdomain to verified access, and using that, it will generate a DNS record for every active resource behind the network endpoint. This way, from an admin perspective, admins don't have to do any kind of DNS management, and your end users get consistent, human-readable DNS names for your resources, which are aligned with your organization. So when you're creating a network endpoint, which is to onboard a group of resources, first, delegate a subdomain to verified access. This is a one-time step. Next, specify a group of resources by defining their IP address range and the ports that you want to enable access to. For example, here, I have defined an IP address range of 10.0.0.1/16 and only allowed ports 22 and 3389, which are specific to SSH and RDP use cases. And once you do so and create the endpoint, verified access connects to each active resource in the network that you have defined. And next, it also creates it creates a public DNS record that your end users can use to access these resources. So it's that simple. Just delegate the subdomain, tell us the network that you want your end users to connect to. Not the network, but the resource in the network, sorry. So let's see how this works in action. Suppose you create a network endpoint and give us, behind the network endpoint, your resources scale dynamically. As soon as a new resource is spun up in the network that you define, verified access immediately connects to that resource and creates a public DNS record. Your admins don't have to take any action to onboard the new resource, and your end users can simply use the new DNS record generated to access the new resource created. Now we've seen how you set up verified access, how you define the policies, how you create the endpoints. Let's see what the users need to access this. With this feature, we are launching a new product component, the connectivity client. The connectivity client is a lightweight application that connects your users to their non-HTTP resources. We debated quite a bit internally on whether to build a client or not, because we had a lot of positive feedback on our clientless model for HTTP apps. But we also heard from customers the need for their employees to retain their preferred tools, such as SQL Workbench or Putty. And to do so, we build the connectivity client. This is a lightweight client where users connect once, and the application runs in the background, and they can continue using their existing preferred tools without having to adapt to a new CLI or face any kind of disruption and change. We're launching the support for Mac with both Apple Silicon and Intel chips, as well as Windows 10 and 11. Using the connectivity client, your users can access applications in multiple regions simultaneously. So from an end user perspective, they connect once and access whichever resource they have to without worrying about where the resource is hosted. Further, we have also integrated the connectivity client with our device trust partners agent that runs on your users' devices. So we also have a browser extension which works for the HTTP endpoint. The browser extension is also integrated with the device trust provider's agent running on user's device. Both the browser extension as well as the connectivity client retrieve the user's device's status in real time when the user is connecting to an application and push the same device posture related information for policy enforcement. This ensures that you use the same set of access policies for both HTTP apps as well as non-HTTP apps. And you get the same device metadata from either of the channels. Now, to simplify client operations, we have heard a lot of, from IT teams, we got the feedback that managing clients isn't easy. And to simplify client management, I'm excited to announce that we will very soon be launching the Connectivity Client Manager, which makes client management operations seamless. Let's take a look how. So customers spin up a verified access instance in every region where they have resources and those resources which need to be accessed by their end users. You can spin up a client manager instance. This is a global resource. Define a magic string. This is just a string, and we'll see where this is used. This is used for your end users to connect to the client manager the first time. And then simply link all your verified access instances, no matter in which region they're present, to the client manager. Next, you can deploy the client on user's device. That's all the admins have to do. Let's see what the users have to do. So once users spin up and have the connectivity client installed on their devices, they simply have to enter the magic string that your admin shares with them. Here, my magic string is my company. And once they do that, they will be prompted to connect and sign in with the identity provider that the admin has already integrated with verified access. Once the users sign in, the connectivity client manager pushes the right set of configuration files for the client, specific to the user. So for example, a user from system administration can only access a specific set of resources, while the development staff can access a different set of resources. So you can define that kind of granularity in the client manager. So the client manager pushes the right set of configuration files to the device, ensuring that your users have access to the right set of applications that they need to. Further, if you make any kind of changes, like add new applications, expand to a new region, the client manager will always ensure that the client files on users' devices are up to date, and admins don't have to take any kind of steps. So in a nutshell, admins just have a one-time, two-step client installation setup where they set up the connectivity client manager and deploy the client on users' devices. Next, we also give the option to pre-configure the connectivity client. So you can download the client configuration files from the client manager, and if you want to pre-image them or you have custom MDM workflows, you can deploy the configuration files along with the client itself. Finally, once your users have the client ready and access installed and access the applications, Verified Access logs each and every connection request. Further, as access is continuously evaluated, we log every outcome throughout a user's session. And finally, with each access attempt, we log the user's identity and device-specific metadata in real time in that moment when the request is evaluated, ensuring that you have detailed visibility into who is accessing what, and this can further aid into your auditing, troubleshooting needs. You can analyze our logs using SIM products by our observability partners listed here. That's all from my side, folks. Now let's see this in action. I'm going to hand it over to Bashuman for a console walkthrough. Thank you.
All right. Am I audible? My mic is on? Okay. So thanks, Shobhan and Rajat. I think they have defined the shape of the product. I'll try and sort of put a face on the name, sort of a console walkthrough as to how to make the things which have been described real. What we're going to do is we're going to do a simple console walkthrough where we'll create a verified access endpoint, connect the verified access endpoint to your trust providers. Trust providers have two families. One is your user trust provider, the Oktas and the IAM, IDCs of the world. And then there are the device trust providers, CrowdStrikes and the Jamps of the world. Then we are going to associate the AWS resources to this verified access endpoint. and express our access policies, like the exact policies you want to be evaluated to access your AWS resources. Also, we'll go through a brief sort of walkthrough on the user experience for the connectivity client and the connectivity client manager, which Rajat was talking about. All right. We'll try and keep it simple so you guys can have a sort of bite-sized takeaways from it, but more than happy to field questions later on how to do it in detail. So verified access instance is your top-level primitive for the service. You create it from the VPC console. Verified access is a feature of the VPC portfolio, so you'll find links to verified access straight off the VPC console. You create your verified access, and you attach your verified trust provider. A trust provider is another top-level container for the service, which encapsulates the configuration for your IDP or your MDM. As I said, CrowdStrikes and the Oktas. I personally love using IAM IDC, so this particular console walkthrough is based on the IAM Identity Center identity provider. You could also use a no IDC provider, which many of our customers do use and prefer. Once done, you have your verified access instance and you have your trust providers attached to it. I'm glossing over these details a bit, but since these are independent of the new features that we are releasing, they are common to both the HTTP and the L4 TCP service that we are releasing. So once we have actually set up our AWS Verified Access instance and our trust providers, we can go and create a verified access group. I think Shobhan and Rajat haven't talked about a verified access group, so humor me, give me a couple of minutes to sort of go through what a verified access group is. A verified access group essentially is a subcontainer within a verified instance. It serves two purposes. The first purpose is classification. Within the container of a verified access group, you can add your endpoints in. And these endpoints inherit common baseline policies. So let me sort of make it real using an example. Let us assume you have a finance vertical and an engineering vertical in your IT administration. What you're going to do is you're going to create two verified access groups. You're going to put in your baseline policies that you expect for your finance apps in your finance access group, and the baseline policies for your engineering in the engineering access group. To make it concrete, let's assume that you have a finance access group, and we're going to explore that in a later slide. You add the baseline policy that anybody belonging to the finance group from your IDP can access all the apps in that group. So it provides a box where a family of apps can be added into. The second purpose of the verified access group is sharing out. You can use Resource Access Manager to share your verified access group with specific development teams. So you take your verified access group and you share it with the development team that's working on your finance apps, and they can then develop their apps and place them into the pertinent verified access group, and they automatically inherit the baseline policies without having to worry about it. So it gives you a clean break between the IT or the security admin and the app developer. So that much about verified access group. Again, verified access groups are created in the console. This is the click-through. This is a bit interesting. So you can now write the baseline policies for your finance group. What we're doing here is we're saying in Cedar that the user going to any of the apps in this access group has to be the member of that particular IDC group. This is the example claims that come from IDC with every request that arrives. Notice it has this user in particular is a member of both the groups, but he's also a member of the finance group, so any request coming from this user will be allowed into this access group. Okay, I think we've actually now done the access system. We built out the access system. So now we have a verified access instance. We have brought in our trust providers. And I have a VPC in a region which is running an application. You can SSH into this application, and it has a web server running on port 80. This is not an ideal security setup. It's for a simple, I would not suggest you do this, but so this is what I have, and I need to enable verified access on that application. To actually enable verified access on the application, I create a TCP endpoint, which is a new feature. The existing HTTP and HTTPS are existing features, and the TCP endpoint is the new feature. Note that we have put in a port range, 20 to 80, and an endpoint domain prefix. We'll come back to that. Once we actually create the endpoint, what it does is it creates a public endpoint, an AVA endpoint, and creates the point-to-point connectivity to the ENI, which is fronting my application. Now we have the endpoint, we have the setup. Note that there is an endpoint DNS entry which has created, which Rajat was talking about. And this is, if you do not give us a zone, we will allocate a zone for you in our DNS system and give you a DNS name for your application. A little bit of a segue into the connectivity client manager. So a connectivity client manager is a global service which dynamically distributes AVA config to the clients. Right? So as you add config into your system, the connectivity client can suck it in and distribute it to all the laptops that are running the connectivity client. To use it, first you create a connectivity client manager, give it the magic string, which Rajat was talking about, give it a description, click through, and you have an empty connectivity client manager. The next thing you do is you start adding your VAIs, your verified access instances into it that you need to distribute through this. That is done through the verified access console, verified access controls, because the owner of the verified access instance has the privilege to add it into a configuration that they desire to add. One of the integrations is Connectivity Client Manager. You add the VAI in, and boom, you have your verified access instances associated with your Connectivity Client Manager. This slide sort of illustrates that it's a global service, and you can have multiple access instances spread around the globe. But you can distribute them in a unified way to your workforce. Now we are all ready to start up the connectivity client. If you remember the magic string, this is the one. This is the identifier you distribute to your workforce. But hey, when the connectivity client comes in, just punch this in. They punch it. It's not a password. To be super clear, it's not a password. It's an identifier. It's a unique identifier. That's it. The connectivity client, once it has access to the magic string, will then ask you to authenticate, your user to authenticate. If you remember, we had used IDC as the trust provider. So you see an IDC login screen. If you had used Okta as your trust provider, you would see an Okta login screen. And then when the user goes and authenticates with her creds, the connectivity client then goes and connects into the VAI. At this point of time, you have a secure connection between the user and the verified access instance. For simplicity's sake, I've just put one verified access instance there. There can be multiple numbers which it globally connects to once you have logged in using your IDP. Once your connectivity client is available, you can use your standard tools now to connect over TCP to your endpoint. As an illustration, the standard tool here being the browser, you can just punch in HTTP and the DNS name that we gave you, and it will securely connect to your resource inside a private subnet inside VPC, and it will work like a vanilla TCP connection running HTTP. Similarly, you could also use SSH on the same DNS name. You just SSH into it, and your users will have the illusion that they are directly connecting into that resource, but it actually is going through steps of fine-grained authorization and authentication through your IDP and authorization through the verified access endpoint. Every connection request, successful or otherwise, is logged, which we think is important. And every TCP connection request is actually decorated with the user that it came from. So if you try, let's say I SSH'd into that particular instance at 2 a.m., the IT administrator knows that a connection to port 22 has been made at 2 a.m. from Bashman. So it's a useful feature for both forensics and troubleshooting. And that sort of ends my console walkthrough. Shobhan has a few key feature callouts he would love to make. So, Shobhan.
Good. Okay. Seems like the mic lost the connectivity, but apparently there was no log, so we can't troubleshoot it. So we'll just continue. So anyhow, so we walked through the feature that we are launching, but there are few other key features that many of our customers use, and wanted to just walk you through those features quickly. One of them is that for HTTPS endpoints, we support WAF integration. Many of our customers want to build a perimeter just to block traditional threats such as DDoS or bots or SQL injection. So we have WAF integration. You can create a web ACL and put it in front of your HTTPS endpoints. Then the second one is the policy assistant. In the early phases when you are writing policy, so it's an iterative process and you want something which helps you quickly. So it's a graphical interface, it pulls down your policies, it also pulls down the log, so it actually has the identity, groups, claims, device claims, and you can simulate the policy. You can change the policy on the fly there, right there, simulate the result till you are happy and then check it back. So that's a good way to come up with the right policies in a quick amount of time. Having said that, we say in the early presentation we said that we want to provide best in the class connectivity for our customers based on their connectivity needs. One of the other products very popular is client VPN. So I will just walk through which one to use when. And before going there, a brief overview of client VPN. Client VPN is a managed service, so it scales elastically based on how many users are connecting, what is the bandwidth requirement, so you don't have to manage anything, any appliance or infrastructure. And then it also provides granular control. You can say which user, which group can connect to your network, your AWS network. Based on that, they are connected and they can access the resources. And the third thing is that it also provides an easy way to work remotely. User just downloads the client and they connect to the network and access all the resources. And this is how it works, right? From the client VPN client, a secure tunnel is created to the endpoint, and then from the endpoint, they access the resources. Before the connectivity is established, you can authenticate the users using either a certificate or Azure or Active Directory integration or your identity provider using SAML. You can also create a connection handler. So connection handler, you can write custom scripts to pull in users, users' credentials, their device information. Essentially, you can build a posture assessment, and based on that you can establish the connectivity. Now, when to use which one? It all depends on your connectivity needs, your security needs, how much trust you have on the users, and what is your audit requirement, how granular you want your audits to be. For example, if you have high trust on your users and you want those set of users to connect to your network and then they can access anything within the network, and you want to audit at the connection level, then client VPN is the right tool for you. Because it's a well understood technology, VPNs have been there, many customers feel comfortable, so it's easy to operate, go with client VPN. If you have zero trust requirements, if you have granular access control, you want to log and audit each and every connection request, so then go for AWS Verified Access. And now I am coming to the last slide, which is the pricing. Our pricing philosophy for verified access is that we want to enable you to migrate to zero trust at your own pace, right? For example, if you have 10 applications, highly sensitive applications, you want to provide granular control, you can move them to AWS Verified Access, or you are coming up with a new set of applications, you just want to move them to Verified Access and you want to keep on your existing connectivity method, so you can do that. So that's why we predominantly charge based on the endpoint, HTTP endpoint or the TCP endpoint. For HTTP endpoints, there is a guardrail of data processing. It's a very minimum amount, and it's all human generated traffic. For most customers, this is an insignificant amount. And then similarly, for the non-HTTPS connections, we have 100 connections, 100 user connections are free with each endpoints, and beyond that then we start charging. Again, it's a very nominal charge. And to give you an example, right, how the free structure works, let's say you have 4 endpoints. So with 4 endpoints, you will get 400 user connections free. So till 400 users connections, there is no charge. Once you exceed 400 user connection, then we start charging for it. Having said that, that was the last slide, and thanks for attending this presentation. And just to remind you, go to your app and then provide us feedback, give us the speaker rating, we'll appreciate that. And we are hanging out here. If you have any questions, feel free to ask us and happy to answer those. Thanks.